Alright guys, today we're doing another LeetCode problem. So today's problem is island perimeter, and we are given a map in the form of a 2D array where 1s represent land and 0s represent water. So grid cells are connected horizontally and vertically, but not diagonally. The grid is completely surrounded by water, and there's exactly one island, which is just a bunch of land connected together. So the island doesn't have any lakes, meaning that we can't have any zeros inside of our island. And the grid is rectangular, width and height don't exceed 100. Determine the perimeter of the island. So guys, for this particular problem, I want to jump straight to the whiteboard so that we can get a better understanding of how to do this problem. Alright guys, so in order to solve this problem, I want to go through this example right here. This is the example taken straight from LeetCode. So with this example, we have to keep two very important things in mind. The first thing is that we need to know what water is, and the second thing is we need to know what land is. So let's try to figure out which is which. So in the problem statement, it's noted that every one essentially is land. So to denote land, I'm just going to mark every single one. And so a collection of all of this land forms our island, pretty much. And we also need to note that anything that is not a piece of land is essentially water. So for every section of water, I'm just going to label those as blue. And there's one more thing. Anything outside of the grid is also water. So all of these four edges here are pretty much just more water. And there's, I guess there's one more thing that we should also note. At any cell that we're currently at, we can only move up, right, down, or to the left. So there's no diagonal movement allowed, essentially. So since we know what our land is, we know what our water is, and we also know our constraints for movement. It's important to actually jot down what our goal is here. So our goal is to figure out the perimeter of our island, which is just made up of smaller pieces of land. Alright, and in order to get the perimeter of our island, we're going to iterate through the entire matrix, starting from position 0, 0. And as soon as we hit a 1, we're going to check all four sides. So if we're at position 0, 1, we'll first check up, right, down, and to the left. And if at any point we go out of bounds or we see a 0, we're going to update our perimeter. So I wrote perim short for perimeter. Essentially, it's going to start off at 0. And if we're at position 0, 1, as you can see, on three sides we have water. So we will update our perimeter from 0 to 3. And we're going to do this for every one that we see. So now we can move on to position 0, 2 here, and we see that we have a 0, so there's really nothing to do here. We only care about all of the 1s. So now we are in this row right here. We're at position 1, 0, and we do see a 1. So as we said before, whenever we see a 1, check all four cardinal directions for water. So we can see that if we go up, we have a 0, so that's water. If we go to the left, we would go out of bounds, so anything out of bounds is water as well. If we go down, we have water. To the right, we have land. So on three sides, we have water. On one side, we have land. So we're going to add 3 to our perimeter, and our perimeter would now be 6. Okay, so we move on to position 1, 1. And we see at this position, if we go up, to the right, down, or left, we have land on all four sides, so we cannot update our perimeter. Now, once we're at position 1, 2, we go up, right, down, left. It looks like we have water on three sides, so we're going to add 3 to the perimeter yet again, and we now have 9. And then position 1, 3 right here is a 0, so there's really nothing to do there. So now we move on to the next row, and at position 2, 0, we have a 0, so move on. but at position 2, 1, we have a 1 right here. So again, we check up, right, down, left, and it looks like we have water on 2 sides. So we're going to add 2 to our perimeter here. And after taking care of that piece of land, there's no more land in that row, so we move on to the next row. So now in our final row, if we're at this one here, it seems that we have water. We have water if we go down. We have water if we go to the left, up, but to the right we have land. So for this particular case, it looks like we have water on 3 sides. So it looks like we have one more piece of land. So at this last piece of land, we can go down, right, up, or left. And it seems that we have water on 2 sides. So we add 2 to our perimeter, and we get 16 as our final answer. And this is the answer they got on LeetCode as well. So it looks like we're correct. So now we ask ourselves, what is our time complexity? So for this particular solution, since we're iterating over the entire matrix, our time complexity would be order of m times n. And so the question is, can we do better? And the answer is absolutely we can. So we need to note that we are actually doing extra work. We're doing more, we're checking cells that we don't need to even visit, right? We really only need to visit the ones. So how do we ensure that we only visit ones and nothing else? Well, the answer to that, guys, is DFS. We're going to use depth first search, and in this case, we would only make one call to DFS, and then from there, since all of the ones are connected, our DFS function will search the entire island, and eventually all of the cells in the island will be visited, and we're just going to do, and while we're visiting these cells, we're going to do what we did in our brute force approach. And what do I mean by that? I mean that, say we're at this cell here. Once we get to this cell, we're going to check all 4 cardinal directions just like we did before. Only this time, we're only going to make these 4 calls on all of these ones here, rather than the zeros. So just with this optimization, our time complexity would be order of v plus e, where v is the vertices and e is our edges. So as you can see, this is a much better improvement. Alright guys, so this is the rough outline for our DFS function. So we're going to have a variable called count, and now that I think about it, I probably should have just called this parameter instead, but we'll go with it. So within our DFS function, we're going to give it a grid, and we're going to give it the position where we're currently at. So if we are at a 0 or we go out of bounds, we know that we're at some piece of water. So when we're at some piece of water, as we saw in our previous example, we want to increase our perimeter, right? And then from there, we would just return. Otherwise, if we're at a 2, that means we're at a cell that we've already seen before, because a 2 denotes a visited cell. And in that case, we would just return and do nothing. Otherwise, if these 2 checks don't get set off, that means that we are currently at a piece of land, we mark it as visited, and then we do a DFS on its top, right, bottom, and left. Alright guys, so now that we actually know how to solve the problem, we can jump straight into the code. So first things first, we actually want to have something that we can return back to them. So we're going to create a variable called perimeter. And within our function, we're going to initialize it. Alright, cool. So before we can jump into the code, we actually want to do some quick error checking. So if they give us nothing to search, then we're just going to return 0 to them. So if the grid is null or the length is invalid, we're just going to return, sorry about that, return our perimeter. Alright, cool. So now that our error checking is done, let's iterate over the matrix. So now that we're iterating over our matrix, as soon as we hit a 1, so if grid at ij is in fact a 1, then that's our interesting case, Otherwise, if it's a 0, then just do nothing. So if we hit a 1, we want to run our Dfs function on, we're going to give our Dfs the grid, we want to give it our row, and we want to give it our column as well. And after we run Dfs, we can just return our perimeter. And just so we don't have any errors here, we're going to return the perimeter down there as well. Alright, cool. So essentially, this is pretty much the rough outline of everything we need. All we need to do is just complete this Dfs function. So without further ado, let's write that function real quick. So it's going to be called Dfs. We're going to pass in 2D grid, our row, and our column as well. Alright, nice. So the first thing we want to do in our Dfs function is we want to see if we're at a 0, and we want to see if we're out of bounds, because in both of those cases that means that we are at water. So if I is less than 0, so if I is less than 0, or I is greater than or equal to the grid's length, or j is less than 0, or j is greater than or equal to 0 length, or grid at I j, sorry about that, is a 0. So if we are at water, we want to increase our count. Otherwise, so if grid at ij is visited already, so if it's a 2, we would just return, and before I forget up here, we would also just exit our Dfs. So what do I mean by this? We're about to see, but essentially after we visit a piece of land, we're going to mark it as visited as a 2, and we're just going to move on. So this is what I mean. Essentially, we're going to say grid at ij equals 2, because if we make it past these 2 checks, that means we have to be at a 1, which in that case we mark it as visited with a 2. And essentially all we really have to do is just call this function 4 times, so in all 4 directions. So we're going to give it the grid, we're going to give it I plus 1, actually let's do I minus 1 first, so that's our top, and then j is just going to stay the same, and we can just copy this guy over and over. So we got our top. Now let's do the right. So to go right, we do j plus 1, and now let's go to the bottom. So we add I plus 1, j stays the same, and then if we want to go to the left, we're going to stay in the same row, but we want to move left. So we're going to make those 4 Dfs calls, and hopefully we're good. Everything looks okay. Count. Oh, why did I say count? Sorry, I meant perimeter. My bad. Let's do this again. Okay, so it looks alright so far. Let's see what happens when we submit. Okay, so that took a while, but we did get our submission accepted. So yes, guys, that is how we solve, I think it's called island perimeter. Let me check. Yeah, so that's how we solve island perimeter. I hope the video was helpful for you guys, and I'll see you in the next one.